All right, back into TCP, but the other two functions for TCP are reliability and flow control, because TCP is reliable and it guarantees an orderly delivery of message. So what happens is, during the initial setup, I'm going to tell you what my initial sequence number is, and that initial sequence number for each segment is upgraded going all the way through. So if you take a look at what happens during a normal process, I mean, I've got data, we segmented it into different parts, I'm sending them one at a time, but based on the different routes that the packet went, they don't all arrive in the same sequence. So I sent 1, 2, 3, 4, 5, 6, and then ended up being 1, 2, 6, 5, 4, 3. And so what has to happen? I've got to reorder the segments to its original order. So that's where TCP uses that, places the data in the correct sequence. I'll let you watch the video on how it does it. Now the question is when it comes to reliability, what happens? I mean, how do I know that the package I've sent, what happens when the data gets corrupted? And then what do I do with it? Well, TCP being a reliable network, it would want to retransmit the data. So no matter how well designed your network is, it's going to have problems. Packets are going to get dropped and lost. But TCP is going to rely on that sequence number and acknowledgments to decide you've accepted the package, you've signed for it, and then I've told you signed for it. So it's in this constant communication, and it's the sequence number and acknowledgement number that it says I've got the same information. So what happens when the system goes through? It says, okay, in cases like this, you see in segment 1, segment 2, 3 failed, 4 failed. So what happens is I've received 1, I've received 2. I'm going to send back an acknowledgement. I'm expecting package 3. The package 3 didn't get here, so what has to happen? Package 3 has to be retransmitted and go through. Now this, how often do I, send a response back? That depends on your establishment as to when you set up that session, how often, how many segments do I need before I get an acknowledgement. It could be 1 for 1. It could be 1 every 5. It could be 1 for, whatever. In this case, it says, hey, I'm going to send it as many times as I want until I get a failure. So just know that when hosts, operating systems typically try to employ a TCP feed called selective acknowledgement. You negotiated doing a 3-way handshake, and even though both hosts support this feature, the receiver can't explicitly acknowledge which segments, but the sending would therefore only retransmit missing data. So in here, I'm not going to retransmit anything other than the stuff that was, so I lost 3 and 4. So what had happened here? I acknowledged I received the last one I received correctly was 3. I'm accepting 5 through 10. So it's telling me I've lost 3 and lost 4, so I'm only going to retransmit 3 and 4. And then acknowledge 13. So it's just kind of a faster way of giving the sender an update as far as how often I'm going to retransmit things. I'll let you watch the video there. The other side of the coin here is, how do I manage the flow of information between the sender and the receiver? TCP has mechanisms for flow control, and basically all flow control is the amount of data that the destination can receive and process reliable. And it just helps maintain things. Now, to do this, the header has a 16-bit field called window size. And this window size gives you, here's just an example here. 3-way handshake. I've got a window size of 10,000, and I've got the maximum size field that I can deal with at any one time of 1460. So I got a sending window of 10,000. My first sequence number, what am I doing? I'm sending only my maximum size is 1460. So I'm going to do 1460. I'm acknowledging, giving you a new window, 1460. So even though it's telling you this, the window size determines the number of bytes that can be sent before expecting an acknowledgement. So just kind of a way of gauging, you can have that. You can, like I said, you could give me every 1460 I want an acknowledgement. But it's putting a lot of overhead on the network, so you're minimizing your data throughput because of all the additional overhead. So that window size determines the number of bytes sent before expecting an acknowledgement. I'll let you go through that. Now this maximum segment size allows me to tell me how many bytes of data within the segment, not the whole frame or the whole package. It's how much data. So in that payload of that packet, how big can it be? What's the maximum segment size? So when I'm breaking down War and Peace into smaller pieces, I'm looking at MSS here, this maximum segment size, to determine how I'm breaking it down. I'm still going to attach overhead stuff on it, so it's going to be large. The amount of information goes across the internet because I got IP address, MAC addresses, CRC information. All of that's additional information that gets added, but it still says that data portion of that packet that's being sent can only be 1460. Now, 1460 is common in IPv4. If on an Ethernet interface, you'll see something called an MTU. I think it's maximum transmission unit or something, and it's 1500 bytes. So it stays within that realm. So you kind of see what's happening. Now, I know how much data is going to be sent. I got to know how much. I got segments now. I got. Now I got to worry about how I'm going to manage so I don't overflow the receiving end any more than I have to. I do that with flow control. Now, TCP congestion control is basically going to use segment numbers and acknowledgments to control how much data that it's going to get. Now, in theory, there's a lot of other stuff there. Actual congestion can be handled with timers and algorithms, but basically for the purpose of this class, just know that TCP is saying that, hey, I'm going to use the sequence number and the segment numbers to say, what am I expecting? Acknowledge it says I sent segment 1, 2 and 3 failed. It received 4. So it says, hey, I'm sending you back, I'm acknowledging receipt of 1, but resend 2. So then you get resend 2 and 3 and go from there. So I'll let you go through the rest of the information here, and then we'll get into UDP communication to be the last video on this for this module. Have a nice day.